Welcome back, everyone. In this video, we will be covering the first half of Lecture 9. The topic is option price decompositions. Decompositions are going to answer the following question: what are option prices made of? In the first half of the lecture, we will learn that option prices are made of two components. The first is something called intrinsic value, and the second is something called time value. In the second half of the lecture, we will relate intrinsic value and time value to the moneyness of an option. That is the option in the money, at the money, or out the money? And we will also relate these concepts to the early exercise of American options. Okay, let's get started. Our setup is the same as usual. We have two dates, 0 and t. We always have our timeline. Date 0 is today. We know what's going on today. Date t is the future. It's the unknown. We have a call and a put option. The call option has a strike of K, a price or a premium of C0, and a maturity of date t. And the put option also has a strike of K, a price of P0, and a maturity of T as well. For simplicity, let's just assume that the underlying asset is a stock for both of these options. Our goal is to decompose the call and put prices into two components: intrinsic value and time value. So we're going to perform this decomposition separately for both calls and puts. So without loss of generality, we just start with the call. The call price can be linearly decomposed into intrinsic value and time value. So the call price, C0, can be decomposed into the sum of intrinsic value and time value. What is intrinsic value? Intrinsic value is going to be the tangible value of the option. It's going to be the payoff of the option if you assume that it expired today. Or alternatively, it's the value of the call if nothing changed between today and date capital T, the future. How do we calculate the intrinsic value? You just take the maximum, and here's where the big difference is. You just take the maximum of S0, the stock price today, NK, and 0. It's extremely similar to the payoff of the option, which we normally denote by C capital T. But the only difference is that the payoff of the option considers the maximum of S capital T minus K and 0, while the intrinsic value looks at S0 in the option payoff function. It's assuming that nothing changes between now and date capital T. What about time value? Time value is just the call's value above its intrinsic value. It's the portion of the call's premium that's attributable essentially to the amount of time remaining on the contract, the optionality. How do we calculate it? Just take the call price or the premium and subtract the intrinsic value. It's just the residual value. In most cases, the time value is going to represent the majority of an option's price. Therefore, we'd like to really understand what goes into this component a little bit better. It turns out that you can perform a similar decomposition for the time value of the call option. You can split it into two components. The time value is equal to something called deferral plus something called potentiality. What is deferral? Deferral is just the value of deferring payment of the strike in the case of exercise to a later date. The idea behind deferral is really simple. It's just time value of money. For example, suppose you exercise the call option. Then what you're going to do as the owner of the call option is pay the strike K at a later date. Now, paying the strike K at a later date is unambiguously better than paying the strike today at date 0, because you could instead use that money used to pay for the strike to invest in something else. This deferring payment value is what deferral captures. So how do we calculate it? That's what's important. We just calculate the interest saved by deferring this payment K to the later date T instead of today. You just take the strike K, which is how much you have the right to purchase the underlying asset at, and you multiply it by essentially the amount of interest that's earned by investing K at date zero. It's the amount of interest you save by paying K at the later date instead of today. Just take the strike, multiply it by e to the RT minus 1, and that gives you deferral. Note that this quantity is usually strictly greater than 0, but it's always weakly greater than 0 as long as the interest rate is positive. Okay? Deferring payment is beneficial to the call because you push that payment to the future at the same value you've agreed upon today. So what about potentiality, the second part of time value? Potentiality is just going to be the final portion of time value that's attributable to all these things that we normally associate with options, such as uncertainty, volatility, and the insurance value. It's going to be the value essentially of keeping your options open between today, date 0, and the future date, capital T. Potentiality is usually the largest portion of an option's price, so it's the largest portion of time value, which itself is the largest portion of the option's price. How do we calculate potentiality? Just take the difference between time value and deferral. Okay. Potentiality is just this residual time value that's left over once we net out the value of deferring payment. Okay. So in summary, what do we have? Call option can be decomposed into two components, intrinsic value and time value. Time value can also be broken down into two components itself, deferral and potentiality. Time value is usually the largest portion of an option's value. And within time value, potentiality usually reigns supreme, but deferral is not something to scoff at. It's going to make up a material amount. We'll see this in this practice problem. I'll give you about a minute to read it, and then we'll work through it. Okay, so the problem statement is as follows. Today's price of Apple is $300 per share. A retail investor is going to purchase a European call option on Apple with a strike of 305 and a maturity of 1 year. The investor is going to pay a premium or price of $34.50 to purchase the call option. The continuously compounded risk-free interest rate is 5%. We're going to ask three questions. First, what is the intrinsic value of the call option? Second, what is the time value of the call option? And third, what is the deferred payment and potentiality value? Okay. To solve the problem, we start by writing down the inputs. So we have that the current asset price today, as 0 of Apple, is $300. We have a European call option on Apple. The strike on that European call option is 305. The maturity T, capital T, is 1 year. And the option premium or price is going to be $34.50. That is, we pay $34.50 to receive the right to buy Apple at $305 per share in 1 year. In parts 1 and 2, we want to decompose the call option price, C sub 0, into intrinsic value plus time value. And in part 3, what we want to do is we want to further break down time value into its two components. It's going to be equal to deferral, or the deferred payment value, plus the potentiality value. Start with part 1, which is to go out and calculate the intrinsic value. Intrinsic value equals the tangible value of the call option. Okay. What's just going to be is the payoff of the call option if it expired today, or alternatively, if there is no change in the stock price between date 0 and date T. It's the maximum of S0 minus K and 0, plug and chug, max 300 minus 305, 0, which is just 0. So of the 3450 call option premium, the intrinsic value makes up $0 of it. In part 2, what we want to do is calculate the time value. Time value is just the remaining value from the call premium after we net out the intrinsic value. Plugging in inputs, it's 3450 minus 0, which is 3450. So note that time value here makes up the entirety of the value of the option. If you were to exercise the option today, for example, if it was an American option, then you would get a payment of 0. It's worth nothing to you. But instead, the time value makes up the largest, the total portion of the premium. In part 3, we want to break down time value into its two components. First is deferral. This is the deterministic component of the premium, the portion that's just attributable to pushing that strike payment into the future. And the second part is potentiality, which is remaining over the amount attributable to the advantages the option provides us over uncertainty, volatility, and gives us an insurance type contract. Okay, so we split this out. We start with deferral. Deferral, the way we calculate it is we just take the strike price and we multiply it by essentially the effective interest rate earned over this period, e to the RT minus 1. It's the interest earned by deferring this payment to the later date. Okay, we didn't write down the interest rate to begin. My fault. It's 5%. Plug in inputs. What do we have? It's 305 times e to the 0.05 times 1 minus 1. This is going to be equal to, let me bring up my calculator here, 1564. Okay, so if instead of paying K305 at date 0, you were to defer it to date capital T, you could have earned $15.64 on that $305. Okay, so the value of pushing this payment to the future is worth $15.64 to you. Potentiality is what is left over. We just take the time value minus this deferred payment value. Plug in inputs, 3450 minus 1564. This is going to be equal to 1886. Okay, so notice two things. First, the potentiality value makes up the largest portion of the options premium. It's well over 50%. But deferral is not insignificant. It actually makes up almost half of the options value. Pushing the payment to the future, pushing the strike price payment to the future, makes up almost half of this options value. Time value of money counts for at least half or nearly half of the options premium. Okay. Okay. So the previous example and the stuff we worked through was all dealing with call options. What about put options? Put options are just like calls. In this case, they can be linearly decomposed into two components. The first is, again, intrinsic value and time value. Nothing changes with intrinsic value except how the payoff is structured. It's still the tangible value here, but this time of the put option. Okay. And what we're going to do, the way we calculate it, is we just take the maximum of K minus S0, that's the big change, and 0. Okay. It's the payoff if the put expired today, or equivalently the payoff if the stock price did not change between now and date 0. We compare it to the normal payoff on the put, PT, which is just equal to max K minus ST and 0. The only difference is that the conventional payoff uses S capital T, while intrinsic value uses S0. Okay. What about time value? Time value is the put's value above its intrinsic value. The way we calculate it is just whatever's left over. Take the put price, P0, and subtract the intrinsic value. Okay. Just like the call as well, we can decompose the time value into two separate effects, deferral and potentiality. But the main kicker here is that deferral is going to work in the opposite direction for the put as the call. While for the call, it's strictly advantageous to defer payment, the put is going to be hurt by deferred payment because it's going to be receiving that strike price at the later date. Okay. So deferral is going to be the value of receiving the strike at a later date. Okay. So in contrast to a call, what this is going to be doing is this value is going to be essentially negative. It's going to be a cost. The reason why, again, is just time value of money. So for example, suppose that you exercise the put. Then when you exercise the put, you receive K. Okay, but the exercise happens at date capital T. Okay, so you're receiving the strike K at the later date instead of date 0. Okay, receiving the strike at the later date K is unambiguously worse than receiving the strike at date 0. So the value of deferral is going to be less than or equal to 0. Okay, it's going to be a cost. You're essentially taking a cost to receive this payment in the future. Okay, the way you calculate it is it's just minus the deferral of a call option. It's the interest lost by receiving the strike at the later date instead of date 0. You just take the opposite of the strike, K, take K, multiply it by -1. You multiply it by this interest adjustment factor, e to the RT minus 1. What about potentiality? Again, same thing as for the call option, really, in terms of the formula and the idea. It's this final portion of time value that's attributable to this uncertainty or insurance component of the option. The way you calculate is you just take the time value, take out the deferral values, whatever is left over. Note that potentiality is going to be similar for calls and puts. They're both going to benefit from this insurance contract over uncertainty, but deferral is going to be negative for puts while it's positive for calls because the time value of money is going to work in the opposite direction. The call gets to defer payment, which you would always want to do, while the put has to defer receipt of cash, which is usually negative or bad for you. Okay? So just like the call, we'll do a practice problem. I'll give you about a minute to read this, then we'll work through it. Okay, so problem statement is again as follows. Still working with Apple. Apple stocks trading at $300 per share today. Retail investor this time purchases a put option, European on Apple, with a strike price of $305 and a maturity of 1 year. He's going to pay a premium of $24.75 to own essentially this put option. Continuously come out of risk-free rate is 5%. Everything here is the same, okay, except now we're dealing with a put instead of a call, and the premium's changed a little bit. Now what we're going to ask is as follows. Okay, we're going to ask what is the intrinsic value of the put. We're going to ask what is the time value of the put. And we're going to break time value into its two components. We're going to calculate the deferred payment and potentiality value. Okay. Solve the problem. Start by writing down inputs, always the best step. S0 is 300. Strike K is unchanged, still 305. Time to maturity here is 1 year. Dealing with a put option with a premium of 24.75. Okay. Risk-free interest rate, we'll remember to write it down this time, is 5%. In part one, what we want to do, or in general for the problem, what we want to do is we have the put premium P0. We want to break this down into its two components and calculate amount. First is intrinsic value plus its time value. Then in parts 3 and 4, or part 3 actually, you want to break time value down into its own constituent components. A time value is going to be equal to deferral plus potentiality. Okay. Let's start with part 1, which is to calculate the intrinsic value. Intrinsic value of a put is just its tangible value. It's the value of the put if, in the case, if it were exercised today. It's the maximum of the strike K, which is what we receive, minus the stock price today, S0 and 0. It's exactly the payoff of the put, except we use S0 instead of ST. Plug in inputs, plug in chug, max, 305 minus 300 and 0, which is 5. Okay, this time we have a positive intrinsic value because the stock price is below the strike at this date. Second part is to calculate the time value of this option. Time value is as follows. It's equal to the put premium minus the intrinsic value, which is equal to 24.75 minus $5, which is going to be 19.75. Okay. Now in parts 3, we want to break down time value into its two components. Time value equals deferral plus potentiality. Start with deferral. Remember, deferral is always bad for a put option because they're delaying receipt of payments. The formula for it is you take minus the strike, multiply it by the interest adjustment factor. It's the total interest you lost by delaying receipt to that later date. Minus 305 times e to the RT minus 1, where we have that e to the RT is just 0.05 times 1 minus 1, just equal to minus, okay, the value we calculate for the call, minus 1564. Okay. Notice that this is less than 0. Deferral is a cost to the put option. Potentiality follows in suit. It's just equal to the time value minus deferral. And here we have to be careful with our minus signs. It's going to be equal to 24.75 minus, and then minus again because deferral is negative, that 1564. This is going to be, check my work on your own, 35.39 or 39.39. Okay. Okay. And so what do we see? We see potentiality is a huge portion of the option value here. Okay. Deferred payment value is negative because we're delaying receipt, but there's a positive intrinsic value to begin with. Oh, excuse me, I made a mistake down here. What we have is 1975. This is the time value, not the option value. And this is 35.39. Okay, so to recap, what do we have? We have put option. Put option can be decomposed into intrinsic value and time value. Intrinsic value, again, is just the tangible value, the value if you exercise the put today. Time value is this little more abstract component, comprised of two things: deferral, which is deterministic, you know what it is. It's the value of delaying receipt of the strike to the later date. You can calculate it just using time value of money calculations. Potentiality value is the more abstract component. It's a value attributable to these, essentially the insurance value or the uncertainty and volatility of the option. Okay. And what that is here is it's a large portion. It actually exceeds the option's price. Okay. Potentiality value is higher than the option's value because the deferred payment value is going to be negative. Okay. So that wraps up the first part of lecture 9. In the next part, after we take about a 5-minute break, we'll finish these two remaining concepts, moneyness and early exercise of American options.